There are two parts of it. One is the obvious idea. To make predictions, we have found out that we need to compute averages, long-time averages, or space and time averages. And an average of an observable A, if your state space, and now I draw it as a circle, but God knows what it looks like. If your state space can be subdivided in fundamental domain and its copies, in this case, this is a pizza cut in 3 pieces, and this is your piece, and this is Kimberly's piece, and this is Burak's piece around the table. In this case, group element is just rotation by cube root, and you're not allowed to flip because pizza would be upside down. So that's called C3 discrete group of 3 elements. The moment we realize we can subdivide the space, we can rewrite our average, which used to be dx of A of x over the domain. We can rewrite it as the sum over the group elements, and their number is the order of the group, in this case 3. And a good average is normalized, so let me be explicit about normalization. Downstairs, the area of 3 slices is the same, so I get the group times the integral over the fundamental domain in my normalization factor. And up here, I get an integral over fundamental domain dx. But just like the last time, I evaluate the value of whatever the function is in the G1, G2, or whatever domain, which means I map my fundamental domain. So you can see that now the averaging splits up into a part which is an integral part. So there is an integral, but now it's integral over the smaller space because we have sliced the space in a piece and its copies. And then just like the last time, we were looking at a position or square of the position averaged, but we allowed the value to be outside of the fundamental domain. So we're doing our computation here, but we're actually measuring the value of function here. That's what this guy does. So now our averaging has split in 2 things. There are numbers which are obtained from the domain, and if there are 6 elements in a group, there are 6 numbers to obtain. So this has now become a vector. And then we average over that vector. So in this way, for discrete groups, finite dimensional representations of the groups will show up. They'll have to do with how you permute or move around values of these elements. So that's first idea. So that's totally sensible. Everybody would get to this.